I will now show you a quick demo how to model a frame cross-section in THERM. First, we're going to look at the specification document that can be downloaded from our website. You might want to print this document out and use it as you're following along. At any time during this demo, you can press the pause button at the bottom of this window or go backwards and forwards as you are following along. The specification document shows what underlay we're going to use, what spacer we're going to use, the buildup of the glazing systems, and the various materials that we're going to use in the file. We're going to switch to THERM, and we're going to select File Underlay so that we can browse to an underlay. We're going to go in here, and the underlay, as we saw, was in Program Files, LBNL, THERM5 Samples. This is the default location if you install the THERM program. I'm going to click Open, and then this underlay was drawn in inches, so the units in the underlay are inches. We can still do the rest of our work in millimeters, but we have to select inches here, and we're going to click OK. So what we have here is the underlay, and we're going to trace these polygons so that we can draw the whole frame cross-section. We're going to start here by doing the Draw Polygon, clicking, and we're going to select the type, and this is wood, and it's pine wood, so we're going to select this here. Now, to draw, it's very useful to learn about zooming in and zooming out with the mouse. When you right-click with the mouse, it will zoom in where your cursor is located. If you press Shift and right-click, it'll zoom out. Right-click, zoom in. Shift, right-click, zoom out. Control right-click will zoom completely out so you can see the whole cross-section. So I'm going to press right-click here, and now I'm going to do a normal regular left-click and start drawing. As I'm drawing, you can see that I don't have to be exactly in the right place, but THERM will automatically snap to a point on the underlay. To see where THERM will snap to, you can also press the space bar, and as you can see, it just snaps to the corner. So I'm going to do Shift right-click to zoom out, right-click to zoom in, so that I can trace along the points very easily. Now if I accidentally click on a wrong point, like here where I went too far, I can press the Escape key and it goes back. It might not draw, there might be a problem refreshing from the underlay, but you can usually find where you have to keep drawing. So I'm going to keep drawing here. I click on every corner, click, click, click. Now here I'm going to zoom in again, so I'm going to right click a few times, zoom in, and make sure I click on the corner here, Shift right click to zoom out, click. I'm going to zoom in here, click here, click here. Now the first point of our polygon was right here. What I can do now is press C on the keyboard and it will close the polygon for me. It will go back to the beginning. So I'm here and I press C and it closes the polygon. It goes straight to this corner and closes it up. So now I'm going to draw the next section. I'm going to select Draw Polygon, make sure it's still set for pine and wood, and I'm going to start drawing here. And I'm going to zoom in a little bit, right click, click here, click here. Now if for some reason you want to delete the whole polygon, as I described earlier, when you click on a wrong point, you can hit Escape and it goes back. If you hit Escape again, it'll ask you if you want to delete the last point or delete the whole polygon. So let's delete the whole polygon and start again, just so we're sure that we do it right. Click, click here, click here, click on this corner, Shift click to right click to zoom out. And now again I can press C so that it closes the polygon to the beginning point here. So C and it's closed. Next one is this one. So again, draw polygon. I'm going to go here, here. It's good to also draw at the intermediate points, put a point there, even though the line is straight. shift right click to zoom out. And again C for close to finish up the polygon. So now we've drawn the essential parts of the frame. Now we need to look at the glazing system. And the first thing we're going to do is define where the lower left hand corner of the glazing system is going to be. And what we use for that is a locator. So we're going to go draw locator, and we're going to just click on this corner here. Oops, and you see that the locator went to the wrong spot. I wanted it to be here, it went here. So I'm going to go again, draw locator. I'm going to zoom in a little bit more and click here, and now you see it worked well. Control right click to zoom out. For the glazing system, these are two pieces of glass, a cavity, and another inner pane of glass. What we're first going to do now is measure the geometry so we can create a glazing system that will fit in here. When we click on the tape measure tool here, we can click on a starting point, and as you can see it picked the wrong point because these points are very close together. So I'm going to hit escape. I'm going to select the tape measure again and zoom in a little bit more. Click here, and we can see this is 4.699 millimeters, which means 4.7. So I'm going to do shift right click to zoom out a little bit. Now we're going to measure the glazing cavity. So again we click here, we click at the end point, and it shows us it's 16.51 millimeters. You might want to write these values down when you're doing your own drawing. And I'm going to measure the inner glass pane. So from here to here, 4.7 millimeters again. And now I'm going to measure what's called the spacer height. That's from here to here. So I'm going to use this tool, and I'm going to measure. And I'm just going to show you what happens if I click all the way at the opposite corner. What you see is you see the length of the line, but you also see the distance in the x coordinate, which is horizontal, and the distance in the y coordinate, which is vertical. So in this case we want to know the vertical dimension, so that's 11.11 millimeters. The other value we'll need later is the sight line to bottom of glass. The sight line is the highest point on the frame on the interior, so that would be here, and the bottom of the glass is here. And again we can see that the distance in the y coordinate is 11.11 millimeters. So now we are ready to construct the glazing system. So I'm going to switch over to Window, and I'm going to go to the glazing system library, and I'm going to create a new glazing system. And now I'm going to double click on this so that I can see the detailed view. And when we look at our specification document, we saw that the outer pane is a low E with ID 9923. So what we do in here is we say it's a two-layer glazing system. We click here and we type 9923. Now we can see that this is a low E coating, and the low E coating is not facing into the glazing system. This is the gap, this is the inside. The low E coating should be here on surface 2. So I'm going to click flip, and it'll be on surface 2 here. You see it moved from here to here. Now the inner pane was 9803. I'm going to go in here, and in here type 9803. And the air gap was 16.51 millimeters. We measured that in the file. So 16.51. And remember, we measured the glazing to be 4.699 or 4.7 millimeters. So that works. This glazing system will fit. So now we've made a glazing system. We're going to give it a name. I'll call it demo sample. And we can calculate it and save it. After we calculate, we see down here the U factor and the solid heat gain coefficient, and now we can use this glazing system in THERM. Up here you can see in which window database I'm currently working, and it's good to note that this is in window 5 called w5.mdb, which is the default. And I go back into THERM. I've set my locator, I've checked that the dimensions work. So now I'm going to go glazing systems, and in the libraries, and import it. And it says I've changed the file since it last loaded. That's fine. And I'm going to make sure that I'm pointing to the right library. So, if you remember when we were just looking that it was in Window 5, the library W5MDB, that's where Window worked in. So if I go in here, I should see the demo sample. There it is, that we just made. 2 layers, 1.93 U center, U value for the center of glass. And I'm going to click Import. And now there's a fair bit of information that we have to fill out here. The first one is we're going to make sure the glazing system is pointing up. That's the way that we've drawn our cross-section. This is a cavity height for condensation resistance, and we're going to leave that at the default. Sightline to bottom of glass, that's the 11.11 millimeters that we measured earlier. Spacer height we also measured earlier. This is a default value, the edge of glass, it's 2.5 inches or 63 millimeters. And this is also default, which we can just leave how high the glazing system is. We don't need to edit those numbers. Then at the bottom we want to make sure we have the right boundary conditions. And it's NFRC 2001 exterior and convection and enclosure radiation. These are the defaults for the program, so if you haven't changed them, they should be correct. And I'm going to click OK. And now I have a glazing system in here, and I control right click, I see the file, the glazing system in my frame. And now we're going to draw in the space between the glass and the frame, and we're going to put a strip of butyl in there. So again, draw polygon, we go in here and we go to butyl rubber, and we click 4 points just like we did earlier. So go click, click, shift click to zoom out, right click to zoom in, this point, and now C to close, and there's our first polygon. And we're going to do it on the other side as well. Click here, click here, click here, click here, and press C for close. So now we've put these in. Now we need to put a spacer in. And in our specification document we saw that there's a spacer is actually in a THERM file called spacer.therm. So what we do is we open up that file, and it's under THERM 5 samples. There's a spacer.therm. And what you see here in the spacer is that we have again that locator that we used earlier for the glazing system. In this case it's in the upper left corner. So what we're going to do is we're going to select all, and then we're going to copy it. Edit copy. So now we've copied the spacer. We're going to go back to our file, and we're going to set the locator in the right place. So if we put the locator in this corner, upper left hand corner, it's going to paste the spacer in this location. It's going to match the locators. So I'm going to go draw locator, right click to zoom in, and I'm going to click here. And you can barely see a little bit of the spacer of the locator. Now I'm going to go edit, paste, and as you can see we've pasted the spacer in. And now I'm going to fill up the cavity below the glass here. I'm going to use the fill tool, and I'm going to make that a frame cavity. There we go. And I click fill anywhere in this area. I'm going to click once, and it completely fills the area. So this is much quicker than clicking at all these points. It just is like a paint bucket that fills up a void. Now I'm going to save my file. I'm going to say File, Save, and I'm going to call it Demo Sample. Now it's time to define the boundary conditions. So I'm going to click on the BC Draw Boundary Condition button here. And it says there's some point in the model that are closer than the tolerance. And first I'm going to tell the program to just mark the points, but don't adjust them. And when I right click here, I see that there's some red circles in certain points. And what happened here is when I pasted in the spacer, it didn't fit perfectly between the glass, so it's overlapping ever so slightly with the glass. Now this is not a problem, because we can go back and we hit the boundary condition button again. It says you already have boundary conditions. We knew that, but we want to just overwrite them. And now we say we automatically adjust the points. And now we see all our circles are gone. So now everything fits. Now we need to define the boundary conditions. In the exterior, currently we have adiabatic along the whole frame, and in the interior as well. We're going to change that. We're going to zoom in here, right clicking, and we're going to click once on this segment here. Now we're going to go shift click zoom out. The zooming in and out is always with the right mouse button. And now we're going to shift left click on the last segment. And last segment, I mean, is on the exterior here. So this is a counterclockwise selection. We picked this segment and then we shift click here and it picked everything in between in a counterclockwise direction. So we're going to hit the enter key and it brings up the boundary condition type library. So I'm going to say what this is. On the exterior it is NFRC 100 2001 exterior. And the U factor tag, we're going to use SHGC exterior, and that's not important right now, but if we import it back into window, that would matter. And I'm going to click OK. I'm going to do the same thing on the inside. This is the inside of the window. And I'm going to go here, select the first segment. We're still counterclockwise. Zoom in here and shift left click. And you can see I've selected all the segments on the interior. And I'm going to press enter and select my boundary conditions. And on the interior, it is what we want is interior wood vinyl frame convection only. And we want to call this frame. What that means for the U factor surface frame is that the heat flow through all these segments that we just picked will be counted for the U value of the frame. So I'm going to click OK. And now I do Control right click to zoom out all the way. And our file is done. I'm going to click File Save one more time. And I'm going to press Calculate. At the bottom here you can see the status as it changed. Now it's done. Now the program is back in inches even though we switched it to millimeters at the beginning. When we click this Switch Units button, it switches between millimeters and the temperatures in Celsius and inches and the temperatures in Fahrenheit. So we're going to do this in millimeters. And now we click the U button here, we can see the U factors. So see the frame U factor of 2.06 and the edge U factor of 2.35, and you don't have to worry about this SHGC exterior one. So now we're done. We've modeled a frame cross section in THERM. We've imported a glazing system from window. We made it in window and we calculated and saved it.